Okay, so let's proceed again with our new problem para sa ating continuation ng lesson. So this is another board exam problem. So yun yung figure natin. Tinatanong lang kung ang deflection ba upward or downward in this given cantilever beam. And to show you the calculations of our given beam. So yan ang ating moment diagram by parts sketch. The given problem. Okay. So solving for EI, TAB is also equal to area A sub B. We're going to calculate now kung paano ba ang value ng EI deflection. Since nakadrawing na yung moment diagram by parts, i-plus ko na lang yung computation. And the value for our EI deflection is 6.67 kilonewton per cubic meter. Alam na ninyo ang pag-drawing ng mga portion na yan na-discuss ko na kanina. So, kaya na ninyong i-study yan kasi marami pa tayong slides. So, medyo bibilisan ko na ng konti. Nakaka 2 hours na tayong maigit pero hindi pa tayo natatapos. Wala pa yata tayo sa kalahati ng ating mga slides. Okay, so let's proceed. Now we have the deflections in simply supported beams by area moment method. So this is another topic. The deflection at some point B of a simply supported beam can be obtained by the following steps. Okay. So this is the geometry of area moment method for finding the formation or deflection in simply supported beam. Laging yung may distance na x, no? Depende kung symmetrical ba o hindi symmetrical yung beam. Kaya x ang ating nilagay dito para safe. Baka mamaya hindi pala yan symmetrical. Kung symmetrical yan, walang problema. Sa midspan tayo. Kaso kapag hindi yan symmetrical, kaya x ang ating inilagay na distance. Kung saan yung maximum deflection natin. Okay? So these are the steps. Compute for TC slash A is equal to 1 over EI, area AC, then X sub C. Compute for TB slash A is equals to 1 over EI, area AB, X sub B bar. That's the second step. And solve deflection by radian proportion, and then you can see the figure above by doing this. Deflection plus TB slash A all over X is 2 TC slash A all over L. So yan yung formula natin na gagamitin regarding about ratio and proportion. So let's proceed. Compute the midspan value of EI to be multiplied by deflection for the beam shown below. So EI deflection, okay? So yun yung ating beam. Symmetrical, di ba? So 1,200 Newton, both sides, yung ating mga reactions. And then, ito yung ating T slash AB. Yung deflection natin sa gitna. By symmetry, ganyan naanap yung 1,200 Newton. And for the continuation, hanapin natin ang TA slash B. Andiyan na yung ating moment diagram by parts kung paano natin ginawa yan. I think alam na ninyo. Dahil uniformly distributed ito, yan, second degree. Kinuha natin sa gitna, no? And then ito rin. And then yung loading natin. Kasi may reaction tayo. Ito yung para sa reaction, yung triangular. Yung para sa uniformly distributed, ito yung nasa baba. Okay, ito naman yung paakyat, ito yung nasa taas. Kasi nga, nag-iba na yung degree eh. Sundan lang natin yung napag-aralan natin sa moment diagram, sa shear and moment diagram. Kung ano yung concept doon, gamitin nyo rin dito. So, mahanap natin dito ang TA/B. And this is going to be the value for our EI at midspan, 3,350 Newton cubic meter. So, napakadali lang. Basta marunong lang kayo ng moment diagram by parts, alam niyo pa rin yung konseptong napag-aralan ninyo sa moment diagram, sa shear and moment diagram, i-adapt nyo lang dito, hindi kayo mahihirapan ng paghahanap ng deflection. And then, samahan pa ninyo ng alam pa rin ninyo yung mga inertia na napag-aralan nyo sa statics, yung mga centroids, yung mga lever arms, hindi kinakalimutan yung mga yan hanggang sa umabot kayo sa design. Another CE board problem. For the beam shown below, find the value of EI deflection at 2 feet from R2. So, yun yung ating given beam. Okay, again. Solution. So, let's solve for the reactions. If we're going to compute for the reactions, R sub 1 is going to be equal to 213.33 pounds. At ang ating namang R2, mahanap natin is 106.67 pounds. After determining the reactions, again, you apply again the moment diagram by parts, yung napag-aralan nyo kanina. Okay, yung mga napag-aralan natin kanina. So, alam na ninyo kung paano pag-drawing. Again, uniformly distributed yan. Okay? Ang katumba dito, ang kinonsider nating point is yung sa gitna eh. Okay? Ito. Kaya yung reaction natin dito, whatever it is, ito yung kanyang 640 over 3. Kasi 2 feet yan eh. 320 times 2, 640 over 3 pa rin. Eh, ito naman yung R1, para ma-review kayo, no? Ito, hanggang doon siya. 640 times 3 times 4 is 2,560 over 3 pounds feet. Reaction lang yung mga data, no? Ayaw mag-divide nung nagbigay na example na yan. So, reaction lang. Okay, so tapos na siya pa ang reactions. Eh, ito naman, uniformly distributed yan. Kaya, second degree curve tayo. Kung ano yung napag-aralan ninyo sa moment diagram, ganun pa rin. Wala namang nagbago dyan, no? Diyan magte-take effect yung area ng spandrel. Okay? So, let's proceed. May formula na akong binigay sa inyo kanina regarding about this spandrel. Okay, 1 over EI, yan. Hanapin na natin ng this A/C para ma-solve natin yung problem. For TA/C, yan ang value natin, no? For the TB/C, yan ang value natin. And then by ratio proportion, sinundan lang natin yung step kanina, di ba? Sabi kanina sa step 1, hanapin muna natin ito. Step 2, you compute for this. Then step 3, by ratio proportion. And this is it. So finally, yan ang ating maximum deflection at point B. Okay? So let's proceed. So ito yung pinapahanap nating EI deflection at B. Okay. Next. So midspan deflections in simply supported beams. Pakibasa nga, Duway, para medyo mapahinga naman yung bibig ko sa kakasabi. Duway? Asan na? Class? Oliver, pakibasa mo na lang.
In simply supported beams, the tangent drawn to the elastic curve at the point of maximum deflection is horizontal and parallel to the unloaded beam. It simply means that the deviation from a centering supports to the horizontal is equal to the maximum deflection. If the simple beam is symmetrical loaded, the maximum deflection will occur at the midspan.
Okay. Continue mo pa, Oliver.
Finding the midspan deflection of a symmetrical loaded simple beam is straightforward because its value is equal to the maximum deflection in unsymmetrical loaded simple beam. However, the midspan deflection is not equal to the maximum deflection. To deal with unsymmetrical loaded simple beam, we will add a symmetrical place load for each load actually acting on the beam, making the beam symmetrical loaded. The effect of this transformation will double the midspan deflection, making the actual deflection equal to 1 half of the midspan deflection of the transformed symmetrical loaded beam.
Okay, so let's proceed. So, nabasa na ni Oliver yung paragraph natin. Ang haba, no? Okay, let's proceed. Now, let me cite you again another example na pwede ninyong ulit-uliting pag-aralan after this. For the beam shown below, show that the midspan deflection is equal to this. So, kumbaga, parang derivation na yan, no? Pero yun talaga ang formula ng beam na to. Now, ang concentrated load P natin, hindi siya actually sa center. Hindi siya sa midspan nakaposisyon. So, A and B. Okay? Take note of this. Isa lamang ito sa mga cases na meron sa superposition method. Later on, makikita nyo mamaya. So, rather na mas maliit ang distance ng A kaysa sa B or mas mataas ang distance ng A kaysa sa B. But in this case, mas malaki yata ang A kaysa sa B. And this is the deflection formula that we have. And in this case, proving tayo. Okay, so how do we prove? We will prove using the moment diagram by parts strategy. Okay? So, nagkaroon tayo ng dalawang P, no? Imaginary yung isa. P dito, P doon. Anyway, layo dito, B. Then there's also B. Naglagay ako ng imaginary to sa una and then kinat ko yan sa gitna. Diskarte lang yan, no? And then we have to apply yung ating ginawa kanina since nasa kalahati lang tayo, no? Symmetrical naman. Kaya P, P eh. Nilagay nila P and then P sa left. Pero P lang dito nakalagay, di ba? Dapat meron dito, no? Naglagay tayo ng imaginary. So R1 is P and then R2 is P. So L over 2 to, and then this distance will become L over 2 minus P because this is B. So yung lever arm dito, L over 2 minus B. So since this is P, and then we're going to multiply it by L over 2, that's why we have 1 na PL. And then yung P naman na nasa ibaba, multiply natin sa kanyang lever arm, then we will have this negative PL over 2 minus B. And then what's next is to calculate for AM. Ito kasi yung middle. So AM tayo. So hanggang dito lang, no? So T slash TA slash M. So we need to calculate for the area of AM. Okay, with respect to A tayo sa yung mga lever arm natin. Kailangan alam natin, no? Apply uli natin yung moment diagram by parts. Now, if we're going to calculate using the moment diagram by parts, yan siya. O, dalawa lang naman eh. Okay? So, ganito yan ha. Baka malito kayo, no? Correct ko lang yung figure, no? So, ito, buo yan. And then, buo yan. Okay, no? Hindi nakakalito. Ito yung para sa 1 up PL. Ito yung kanyang base, L over 2. Ito yung 1 up PL. Ito L over 2. Ayan. Ano? Then 1 up, since triangular yan. And then ito yung kanyang lever arm. Bakit 2/3 of 1 half of L? L over 2 to. Ano ba yung 2/3? Ito yung 2/3. 2/3 ng alin? Ng L over 2. Kasi around tayo sa point na to eh. Di ba? So, ito yung point natin. Okay? O dito, ganun din. Manlayo niya doon. Okay. So, ano ba yung 1 half? Dahil triangle yan, so 1 half. Ano ba yung 1 half? L over 2 minus B. Ito yon yung yung length, yung base ng triangle na to. And then, ano ba yung P times 1 half of L minus B? And this is it. Well, this one is our lever arm. From here hanggang doon. Okay? So, calculating it, we can have this continuously, simplifying this equation. Konting algebra lang ang dagdag niya dito. We will arrive with this value. Alam na niyo yan. Algebra na lang yan. Continue nyo hanggang sa umabot tayo dyan, hanggang sa ating maderive ang ating formula. Okay, at midspan, 1 half TAM. Okay, 1 half eh. And what is the answer? This is it. Ganyan siyang na-derive yung formula natin ginagamit lagi kapag hindi symmetrical yung beam. Okay? So, method of superposition. Ito na yung pinaka-iniintay natin. I think we have 12 cases in this. And I need you to master all these cases. Kabisaduhin niyo yung mga cases na yan, yung mga drawings, yung mga formula. The slope or deflection at any point on the beam is equal to the resultant of the slopes or deflections at that point caused by each of the load acting separately. Rotation and deflection for common loadings. Case 1. So, at yung case 1, ipa-plus ko lang sa inyo, ang katungkulan nyo dito is to makabisado lang or ma-master lang yung mga formulas, yung mga shapes, yung mga types ng beams natin, yung ano ba yung maximum moment, ano ba yung deflection, and slope. Una, ito yung una nating case. A cantilever beam na may concentrated load P sa pinakadulo nito. Okay? And then, what is about this case 1? Una, ang maximum moment kapag ganyan ang ating beam. Ang formula na ating ginagamit, M is equals to negative PL. Case 1 yan, no? And ano ba yung rason? Bakit kailangan yung makabisado? Makikita nyo mamaya. Hindi mo magagampanan ng maigi ang method of superposition kung di mo kabisado ang maximum moment, ang slope, at ang deflection ng bawat case. From time to time, anytime, yung problem na ibibigay ko, maybe isa sa mga case na yan o dalawa o tatlo sa mga cases na yan ang gagamitin ninyo para lang masolve ang problem na ibibigay ko. For maximum deflection, tandaan niyo kapag cantilever beam na may concentrated load na P sa dulo, sa board exam, minamaster yan. PL cube over 3EI ang formula dyan. Hindi mo na kailangan mag-derive dahil maubusan ka ng oras during licensure. Deflection equation, Y is positive download. And this is our equation. Okay? Okay, 4 lang naman yan. Okay. So let's proceed. Case 2. Concentrated load at any point on the span of cantilever beam. Limbawa, ito yung P natin. No, napalitan ng position, wala na sa dulo. No? Again, involve na naman ang distance A and distance B. Maximum moment, M is negative PA. Slope at N, P square over 2EI. And its deflection formula, yan, 3L minus A yung multiplier natin sa P square over 6EI. And deflection equation, y is positive downward. Ini-introduce ko lang yung mga formula, no? Wala pa tayong calculation. Kailangan kabisaduhin ninyo itong mga to kasi mga cases yan. Ngayon, kung paano gagamitin ng mga yan, depende sa given beam na aking ibibigay. And then, gagamitin ninyo ang isa or dalawa sa mga yan para lang ma-solve yung problem. So, maximum moment, cantilever pa rin yan. WL square over 2. Slope at n. Yan. And then, for our maximum deflection, WL to the 4 over 8 EI. And for deflection equation, y is positive downward. Ito yung ating equation. Case 4. Triangular load pull at the fixed end and zero the free end of the cantilever beam. So uniformly bearing na pero cantilever yung type ng beam. Yan. Maximum moment, double square over 6 and slope at n. Theta is equals to WL cube over 24 EI. For maximum deflection, we have WL to the 4 over 30 EI. Deflection equation y is positive downward and it is our equation. EIY is equals to WX square over 120L times 10L cube minus 10L square X plus 5LX square minus X cube. Moment load at the pre-end of cantilever beam, case 5. So, moment lang yung meron, wala tayong concentrated load, no? So, maximum moment, M is equals to negative M, slope at N, ML over EI, and our maximum deflection will be equal to ML square over 2 EI. Deflection equation, Y is positive downward. Kabisadin ninyo yung mga figure at yung mga moment. Paano makakabisado? Mag-drawing kayo nang hindi nyo tinitingnan ng figure and then isulat ninyo yung mga moment and slope at N, maximum deflection, at saka yung deflection equation Y. Nang paulit-ulit, makakabisado ninyo yung mga yan. Okay, EIY is equals to mx squared over 2. Case 6. Concentrated load at the midspan of simple beam. Okay, symmetrical. So, ginawa natin kanina yan. Ano yung deflection formula dyan? Kung natatandaan nyo pa. Dinerive natin kanina yan. Pero dito, hindi ko pinapa-derive. Pinapakabisado ko na sa inyo lahat ng deflection formula. Sa board exam, hindi kayo magde-derive ng formula. Abot kayo ng siyam-siyam. Ngayong nag-aaral kayo, dapat matutunan ninyo kung paano ba mag-derive ng formula. And then, hello? Narinig ba ninyo ako? Hingay ng aso namin. Wait lang, no? Hello, class. Are you still with me? Kanina, ang dami natin. Ngayon, 13 na lang tayo. Hello, Lolo? Okay, so let's proceed. So, yun yung maximum moment natin. Slope at N. Maximum deflection. PL cube over 48 EI. Yun yung na-derive natin kanina. And even the slope. And then, deflection equation. Yan ang mga formula natin. So, that's case 6. Sa case 7 naman, kabisadin nyo rin yan. Simply supported, kaya lang hindi sa gitna yung concentrated load na P. Lamang ng bahagyang A sa B distance. And then ito yung ating mga formula for maximum moment, slope at N, maximum deflection, and also equation. Deflection at center, not maximum. Yan, when A is greater than B. Deflection equation, Y is positive downward. EIY is PBX over 6L times L square minus X square minus B square for inequalities of 0 less than X less than A. And may extra formula pa akong isinama sa pinakababa ng ating slide. Case 8, uniformly distributed load over the entire span of simple beam. Kanina yan yung isa sa mga dinerive natin ng formula ng deflection. 5WL to the 4 over 384 EI, I take ang formula ng deflection dyan na maximum. Maximum moment, W square over 8. Slope at N. Okay, and the maximum deflection, yan yung na-derive natin kanina. And even with the slope, na-derive din natin kanina. Deflection equation Y is positive downward. So, we already have 8 cases. We still have 4 more cases. Case 9, uniformly varying naman. Ito hindi natin na-derive kanina. Pero ito yung formula ng ating uniformly varying load. Moment, W square over 9, square root of 3. Slope at N. And maximum deflection. Deflection equation, here is it. Okay? Okay, let's proceed. Triangular load with C rotate support and pull at the midspan of simple beam. Case 10. Yun yung mga formula natin. Mula maximum moment, slope at N, maximum deflection, hanggang deflection equation. Y is positive downward. Case 11. Moment load at the right support of simple beam. Okay, yan ang ating maximum deflection and deflection at center, not maximum. And for our last case, moment load at the left support of simple beam. Yan. So yan yung 12 cases natin under superposition method. Although medyo mahirap lang kabisaduhin ng mga yan, pero kapag nakabisado, madali na lang ang pagsosolve ng mga problems. So dapat talaga makabisado ninyo yan. Sa pagsosolve, kailangan na marami kayong mga methods na alam para pag umabot kayo ng design, hindi kayo mahihirapan. Sa design, mga minor nyo lang yan. No? Mga tools lang ninyo ang mga yan. Sa pagdating nyo lang design subjects, gagamitin ninyo yung mga formula na yan. Pinapauna ko na sa inyo, kailangan makabisado ninyo. And hindi nyo makakabisado lang pinapanood nyo lang, nakikinig lang. Kailangan ina-apply ninyo. Nagsasolve kayo. Kapag kasi nagsasolve ng actual, ng manumano, doon talaga pumapasok yung mga questions na naiisip ninyong itanong. So let us have one sample problem regarding about superposition method bago ko ibigay yung mga bago ninyong assignments regarding about deflection of beams. Determine the midspan value of EI deflection for the beam loaded as shown below. Use the method of superposition. Now, in this case, may dalawang concentrated load tayo. The 100 pounds and 80 pounds. If I will let you to choose among those cases, what do you think is the case na applicable dito? Natatandaan niyo pa ba yung mga figures? Siguro hindi na, no? Anyway, hindi naman kayo laging kumikibo. Okay, proceed ko na. Ang case na involved dito, okay, no? Kung tatanggalin ko, kung alisin ko, kunwari lang, no? Temporary yung 100 pound. At 80 pounds lang ang nag-e-exist dyan. Ito yung distance A, ito naman yung distance B. Yun yung may P. Yung hindi sentro yung P, yun yung case na inaanap natin. And what is that case actually? That is case 7. Yan ang kailangan natin dyan. Since dalawa yung concentrated load, ibig sabihin, twice na may apply ang case 7 in this portion. But how do we use case 7 here? so that we can solve the EI deflection for the beam loaded as shown. And this is our solution. From case 7 of summary of beam loadings, deflection at center is, yan yung formula ng deflection natin na ibinigay ko sa inyo kanina, that when A is greater than B. Okay? And then afterward, in order to calculate EI midspan is equals to EI midspan due to 100 pound force plus EI deflection midspan due to 80 pound force. So twice tayo. Isa para sa 100, isa para sa 80. So separated sila, kaya lang i-add pa rin natin. So ibig sabihin, yung formula ng deflection natin is twice magagamit. But how do we do that? EI midspan is equal to the summation of PB 48 times real square minus 4B square. And by direct substitution, and paano ba nangyari ano? PB. Okay, PB over 48. PB over 48. So let's start first with this. So L and B. Okay, considering the 100. Okay, considering the 100. Okay? Kung bakit 2 ang nakalagay dito, no? At bakit 2 din yung nandito? Okay. Explain ko lang. Since A ito, B yun, kung titwist natin yung situation, pag nasa 100 tayo, okay, in order to satisfy this inequality, ito muna ang A natin. Okay? Ito muna ang ating A. Ito ang ating B. 2. And then ang A natin is 7. Now, L in this situation is 9. 2 plus 4 plus 3 is 9. And then our B is 2. B is 2. And our P is 100. That's why we have this expression while we are utilizing this expression also. Okay? So, tapos na tayo sa 100. Proceed tayo sa 80. Okay? Paliwanag ko yung 80. Para mas klaro sa inyo, yung sa 80 pounds. Urayin ko muna yon. In this situation now, para mas klaro sa inyo at maliwanagan, ito ang ating A. Ito naman ngayon ang ating B. At ang ating L is equal to 9 pa rin. Hindi naman mabago yan eh. Okay? And since nasa 80 pounds tayo, that's why we have P as 80 and B is equal to 3 and over 48 pa rin naman yan. 3L square is 9. So 3, 9 square minus 4. Ito yung B, ito yung L. Now, simplifying this equation, we can have this. Mas madali ito. Yun nga lang, kailangan kabisado ninyo yung mga cases, yung mga formula. Yun lang ang nagpapahirap sa superposition. Pero maniwala kayo, ang pinakamadaling method is superposition method. Kasi formula na lang ginagamit at mga cases na lang ang tinatandaan. Question so far about superposition? Hindi kayo mahihirapan sa superposition. Ito na yung pinakamadaling method ng paghahanap ng deflection. So our EI midspan is 1,980.83 pounds per cubic feet. Another case. Yan. Okay, 7 pa rin yan. So kamukha lang nung kanina, plus ko na lang yung computation. Okay. Yung EI equation natin, no? L square minus x square minus b square for 0 less than x less than a. So, ibang case 7 siya, pero iba yung formula na ginamit natin. Kasi sinusunod lang natin yung mga inequalities. Okay? Plus ko na lang yung computation para agad tayong matapos. And then, aralin na ninyo yung sample problem na yan. Yan ang ating final answer. For your assignment, using double integration method, compute the maximum deflection of the given beam as shown below. So, paki-calculate ang deflection ng ating given beam para mayroon kayong pagkaabalaan. Number 2, again using double integration method, determine the maximum value of EIY for the cantilever beam as shown below. And for number 3, compute the moment of area of the M diagrams between the reactions about the left and right reactions of the given beam shown below. So this is moment diagram. Okay, next. Using superposition method, determine the midspan deflection of the beam as shown below if A is equals to 10 gigapascal and I is 20 times 10 to the 6 millimeter to the 4. I think combination ito ng dalawang case. Yung concentrated load na P na may A and B, I think case 7 applicable dito. And then yung may simply supported na uniformly distributed, yun ang gagamitin ninyo dito. So combination of two cases. Yun yung int na may bibigay ko sa problem number 4. Anyway, deflection lang naman yan, formula. Thank you and God bless. And that ends our session in this afternoon.